All right, kiddos, so this is our Unit 1, Day 10 lesson recording. And we're going to continue talking about rigid transformations. Today we're talking about reflections. Our EQs are simply what is a reflection and how do we do reflections across four different lines of reflection. We'll talk about what that means here in a second. And let's go ahead and jump right in and answer EQ number 1. So what is a reflection? So the only way to really explain that is, again, to just kind of see it and try to put into words what it means. Okay, so if I reflect that red triangle, A1, B1, C1, D1, I go ahead and reflect that. Okay, what I've got is B2, C2, A2. And all it really is, all it amounts to is I counted my distances. So my line of reflection, forgot to mention that, my line of reflection in this case was across the x-axis. Okay, and all that means is that's where my image is being quote-unquote mirrored, right? And this is important. So what I maintained when I reflected was how far each vertex was from my line of reflection. Okay, so my C1 was 5 away, A1 is 7 away, and B1 was a distance of 5 also. So when I do my reflection, I have to maintain those same distances. So A2 is 7 away, B2 is also 5, and C2 is also 5. Okay? So if I had to define in words what is a reflection, I think all I would say is that a reflection is a rigid transformation. I'm going to abbreviate. Where the vertices get flipped. We'll call it the vertex positions. They get flipped, for lack of a better phrase, and maintain their distance from our reflection line, or our line of reflection. Okay, so reflections are rigid transformations where our vertices get flipped and they keep the same distance from the line of reflection. Okay, so we just did a reflection across the x-axis, right? So literally, what did I do? So how do I reflect across the x-axis? Literally. Let me go ahead and erase a little bit, get this out of the way. So all we did, basically, was count our distances. Okay, so we counted our vertex distances from the line of reflection. Okay, so that's really all we did, and then we just drew it again on the other side. All right, so that's how we literally did it. Now, how do we algebraically do this? In other words, how do we do this with numbers? So let's look at what happened. In order to see what happened with the numbers, well, we need the numbers. So A1 is at -4/7. B1 is at -3/5. C1 is at -5/5. All right, so where did I end up with A2, B2, and C2? So A2 is at -4/7. Okay, so it's the same numbers, right? Except my signs changed on my y coordinate. I went from +7 here to -7 here, right? So that's a little pattern that we'll keep an eye out for. So what is B2? So B2 is -3 by -5. And again, we went from +5 to -5. So there's our little pattern I think we can already determine. Okay, so algebraically speaking, how do we perform a reflection across the x-axis, algebraically speaking? Well, we go from x comma y to, well, all we did was change the sign. We changed the sign of y. Okay? So you just change y sign. All right, so let's look at reflections across the y-axis now. So here's our line of reflection now. This is the y-axis. This is our new line of reflection. Okay, so if we just kind of count, and we do this literally, I'm just going to count my distances. So B1 is 3 away from the line of reflection. So my new B3 here in purple will be 3 away from the line of reflection. Okay. What about C1? Well, C1 is 2 more than B, so it's at 5 away. So that would be C3. And A, we can already tell A3 is going to be there. So again, literally would be the same answer. It'd be the same answer as before, right? We're going to count our distances from the reflection line and just redraw it across on the other side. Okay, now let's look at algebraically. Algebraically is going to be pretty simple. So we went from -4 by 7. Well, now we're at +4 by 7. So again, we have the same numbers, except this time we see a change in the x-coordinate. We went from -4 to +4. What about with C? So C's x-coordinate was -5. C3's x-coordinate is going to be +5. And our y stays the same. Okay, so again, we go from negative to positive. So we already have our answer for how we're doing this algebraically. Algebraically, to go across the y-axis, all we're doing is going from x comma y, and we're just changing the sign of our x coordinate. Okay, so change x sign. That's how we reflect across the y-axis. So now, let's look at how do we reflect a figure across the line formed by y equals x. Okay, and literally, we're not going to worry about literally, because that's pretty hard to answer. We're just going to worry about algebraically. Okay? So, algebraically speaking, so this equation here, this line is the line of y equals x. Okay, and if we had it in the form y equals mx plus b, it would be y equals mx plus, oops, I don't know why I didn't put an x, mx, and it's not going to let me use an eraser. Thank you, Microsoft. You still suck. So our b would be 0 in this case. Okay, so anyway, that's what this blue line represents. I'll go ahead and use blue. Okay, so this is y equals x. This is our line of reflection. So this is our new line of reflection. We're not reflecting across an axis. We're reflecting across an equation. Anyway, if we kind of try to eyeball it, we can kind of count diagonally our distance, right? Our distance from our line of reflection. So this guy right here becomes our B2. right? What about A? Well, let's count diagonally. Okay, so it's 3.5. So half and then 1, 2, 3. That puts me here. And then we can already tell where C is going to be. So this is A2, C2. Right? Okay, so now looking at numerically speaking, right? So what did we change? So A is -3/4. Our new A is 4/-3. Oh, well, what happened there? What about C? So C1 is -4/2. What is C2? 4/-2. I think we've established a pattern. All we're doing is flipping the X and Y. All right? So all I would say here, what happens when we reflect across the line formed by Y equals X algebraically? We're going from X comma Y to Y comma X. We're simply flipping coordinates. Okay, and last but not least, how do we do reflections across? So this is pretty much the same idea. How do we do reflections across the equation y equals -x? So we have a slope of -1 and a y-intercept of 0. Okay, how would we reflect across this line? Well, it'd be the same idea as before. So I'm going to start with B1. So B1 is 1, 2, 3.5. Half, 1, 2, 3. So there's, we'll call that B2. Okay, and again, it can be a little bit mind-numbing to do this, but you can already kind of see if you tilt your head to the left, you can already see how this is going to reflect. Okay, so A1, let's count from our reflection line. So we've got 1, 2, 3, 4 going diagonally. So 1, 2, 3, 4. So that is where, wait, did I count that right? Oh, it would be here. I goofed. That would only be 3 away. 1, 2, 3. I don't know why I said 4. So that would be our A2. So we have a distance of 1, 2, 3, right? And again, 1, 2, 3. Okay, and we can already tell our C2 will be right there. Actually, no, it will not. It would be right there. See, so it's really difficult to do this without the math. It's much simpler if you just do the math, but we're going to see where that comes from here in a second. So this is going to be C2. Okay, and again, I can do that by counting diagonally. So 1, 2, 3, 4.5. Half, 1, 2, 3, 4. And that puts me right here where I need to be. Okay. So let's see what our coordinates are. So A1, we have -4/-2. B1, we have -3/-4. And C1, we have -5/-4. Okay, well, what are our new ones? So let's look at A. So A1 to A2, what have we got? So we've got 2/4. Well, it looks like the numbers switched, and it looks like they also changed sign. Let's look at B1. So from B1, we've got -3/-4. B2 is 3/4. Same thing, numbers, whoops, that should be 4/3. Okay. 4/3. No, brain fart. Anyway, so our numbers flipped, and our signs did also. What about C2? Okay, so we've got 4/5. 4/5. So again, numbers flipped, right? and the signs also changed. Okay, so for our last CQ, again, we're not worried about the literally part on this one. We're just worried about the algebraically. So when we reflect across y equals negative x, all we're basically doing, we're going from x comma y to negative y comma negative x. Okay, so flip signs and coordinates. Okay, and that's all there is for this video, children. If you have any questions or any concerns, feel free to come through tutoring or shoot me an email. Goodbye.